Well, in this discussion, we're going to introduce the idea of graphing the trigonometric functions. And we start with sine and cosine functions and go through a list of different types of effects that kind of like transformations that we've seen when we graphed in the past. As you can see here, I've shown some examples. We're not going to do these in this lesson, but we might like to graph y equal 3 plus 5 times the cosine of 2x, or y equal 2/3 times the sine of 3x, or y equal the cosine of the entity x plus pi over 4. And you can see I've written this in general, and I must warn you that the letters that I use here may not match the ones in the particular book we're using at this point. But we're interested in general in graphing sine and cosine functions where we have y equals some constant plus some constant, I've called it, some constant k I called, plus some constant a times the sine of an expression that is a constant b times x plus a constant c. Now, each of those pieces, k, a, b, and c, will affect how the graph looks. But of course, before we know how they affect how the graph looks, we need to know what the basic graphs of y equals sine of x and y equals cosine of x look like. And on the next page, I've got the graph of y equals sine of x. And it's important to recognize I created this by plotting points. So let's look at this next page. Okay, here's the graph of y equal the sine of x. Now, let me point out to you first, I started out with x being 0. Okay, and then I calculated the sine of x to calculate my y value. Well, the sine of 0 is 0, so we get the point 0, 0, which is what we see right here. Now, furthermore, I came in and I said, okay, because I chose x values that I could calculate with pretty easily. So I chose an x value of pi over 6. That's about right here where you see I'm making these marks or this motion. And if sine of pi over 6 is 1/2, and so the y value is 1/2, and it puts me at this point. And then I chose pi over 4, which is halfway between 0 and pi over 2 for my x value, and I calculated y. The sine of pi over 4 is the square root of 2 over 2. And that is approximately 0.7. So my y value is approximately 0.7, okay, as we see here. And then I chose x to be pi over 3, which is roughly here. And I calculated the y value. The sine of pi over 3 is the square root of 3 over 2, which is a roughly 0.85. So that's, yes, that's why this point is on here. And then I chose x to be equal to pi over 2. And the sine of pi over 2 is 1, and that puts me here. Now, after this position, remember, that's the biggest the sine can get. When I move beyond pi over 2, my sine values are still positive, but they start going down. And we're thinking in the second quadrant of the unit circle. And then when I get to pi for my x value, okay, when I get to pi for my x value, then the sine of pi, of course, which is 0, so that puts me at this point, pi comma 0. And now I'm in the third quadrant, because between pi and 3 pi over 2, I've got angles in the third quadrant, and all my sine values are negative. And they keep getting more and more negative until I bottom out when when x is 3 pi over 2, the sine of 3 pi over 2 is -1. That's the smallest it can get. Now, when I go between 3 pi over 2 and 2 pi, I'm in the fourth quadrant, and so my sine values, again, are still negative, but they're increasing they're negative numbers, but they're increasing until I get to 2 pi, and the sine of 2 pi is 0, so I have a y of 0 here. Now, you can reproduce those by plotting points on your own, but remember, I could have chosen negative x values, and that would have made a part of the graph that looks like this. And I can choose x values that are larger than 2 pi. I make more than one revolution, and this cycle continues. So The one important observation that I've noted down here is that the graph of y equal sine of x is cyclic, or periodic is what we say. It continues forever left and right because we can use any x values. But our y values, remember, the sine of a value is always between -1 and +1, and so our y values here are always between -1 and +1. But the graph oscillates or moves up and down periodically. And in the case of sine of x, that cycle repeats itself every time we make a revolution. And one revolution is 2 pi, and so we say the period is 2 pi. If we look out here, it's starting the same thing that solid line starts, and it's going to do the same thing until we go through another complete cycle. And a complete cycle is up, down, back to up. That's a complete cycle. And as it says here, that repeating cycle is length 2 pi. Well, on the next page, we're going to see the cosine function. Now, I'm not going to go through the same complete description I did before, but once again, the cosine function is always going to give a value between -1 and +1, so y's are between -1 and +1. This time, when I chose x to be 0, y is the cosine of 0, and the cosine of 0 is 1. So we start up here high instead of starting down here like the sine function. And I just went through the same process. You know, the cosine of pi over 2, if x is pi over 2, cosine of pi over 2 is 0, so y is 0, and that's this point. Now, when we get to x being pi, when we get x to be pi, well, the cosine of pi is -1, so y value is -1. And we get back to where x is 3 pi over 2, well, y would be the cosine of 3 pi over 2, and the cosine of 3 pi over 2 is 0, so that's the reason this point is on the graph. And likewise, when we get all the way around for one revolution, we get back to 2 pi, and so when x is 2 pi, y is the cosine of 2 pi, which is 1. That's the reason this point's on the graph. And then it repeats itself. Once we make that full revolution, it repeats itself, doesn't it? So I'm indicating the graph goes forever to the left and right, and just as before, I could choose negative x's, and we would have a graph that looks like this in this direction. But I'm looking at the most important part of the graph, and that's one period of the graph. It is also periodic, and the period of cosine, y equal cosine of x, is also 2 pi, meaning this little image repeats itself over and over and over. Actually, any place we start, if we go 2 pi units, we have a repeating image. See, from here to here is 2 pi units, and that cycle will repeat itself. But we think of this as the home cycle, or the basis of what the y equal cosine function looks like, and it repeats that left and repeats that right. Let's look at the next. Really what I want to point out to you here is in this graph, and I'm looking at one full period of the sine function. Remember, it started low, and then it went up and down and back to the original position here, and it's going to go through that again. So we have one cycle, or one period, x from 0 to 2 pi. And I'm pointing out that there are 5 important parts to this graph. We have so between 0 and 2 pi for x, we have 5 important x values. X value equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. Because those are when something important happens on the graph as we think of the unit circle. Well, the beginning, okay, on the sine function, the beginning starts low, if you will. Starts here at the origin. It's at an x-intercept, if you will. And then the first quarter of that period, see, and stop and think about this. Here's 0 to 2 pi, and what do we have? 1, 2, 3, 4 equal pieces there. So we're breaking that 0 to 2 pi into 4 equal pieces, and that would be each with a piece of pi over 2 in length. Well, in that first quarter period, when we get to pi over 2, the sine function is at the top of its amplitude. It's as high as it's going to go. And then in that second half of a period, in this next position, this next important position, it goes back to a position as an x-intercept. And then in the next quarter position, what's going to happen in this part of the period, this 3/4 part of the period, is going to the lowest part of its amplitude, or the lowest y value that we'll get. And then in this last quarter, it moves back up to the original position, back to an x-intercept. Now, those four important parts, those four important x values, 0, pi over 2, pi, 3 pi over 2, and 2 pi, are also important in the cosine function, but different things happen. Okay, in the cosine function, see, when x is 0, we start high, but at the first quarter point, we're to a x-intercept. At the next quarter point, which is pi over 2, pi, then we're at the lowest place on the graph, the bottom of the amplitude, we say, the lowest part on the graph. And then the next quarter point, it goes back to a position of an x-intercept. And then the last quarter point, the end of the period, it's back where we originally started, isn't it? It's back up high again where we originally started. So if we know where it starts and we know something important happens at each of these quarter points, then we'll have the basis of what that graph will look like. And that's really the note here, is that in graphing the basic sine and cosine function, it's best to know what happens at each of these 5 x values, these 5 key points: x equals 0, x equal pi over 2, x equal pi, x equal 3 pi over 2, and x equal 2 pi. We're breaking from 0 to 2 pi into 4 equal parts using the endpoints as well. So that's very important to us as we do these graphs. So as I started out to say here, we're going to need to be able to, and maybe I'll show some examples of this later on, but if we know that the home interval, if you will, the main interval is from 0 to pi, we need to know how to break that into 4 equal parts and find out the 5 key points. And so 0 is a key x value, pi is a key x value, but we have 3 more key x values in between, and they're the quarter points of this interval. So we'd break the interval in half, and that would be pi over 2. So that's the middle. And then we'd say, oh, well, between 0 and pi over 2, we'd break that in half. Oh, well, that's pi over 4. So now we have 0, pi over 4, pi over 2, and then we're actually going by pi over 4s then, we see. Then we'd go to 3 pi over 4, and then we'd go to pi. So we have our 4 pieces. We'll do that in some actual examples later on. So this is the, if you will, the end of the introduction. I just want you to know that it's important to be able to pick up these values and what the graphs of these two functions look like in general. Okay, in the next video, we're going to discuss a specific one of those numbers, how it affects the graph, and it's called amplitude.